Thank you for joining us today for our seminar in the Journey to Science series at Onondaga Community College. This seminar is sponsored by the Bridges to Baccalaureate grant. Today, we are welcoming Dr. Lee Newman from SUNY ESF. Dr. Newman is Associate Professor and Chair of Chemistry at SUNY ESF right here in Syracuse. She earned her PhD in microbiology and molecular genetics from Rutgers University. Her current research interests include the use of plants to clean up environmental contaminants, as well as the growth of plants for energy production. Help me in welcoming Dr. Newman.
Hello, everyone. So I'm going to give a slightly different talk in that I'm not going to start out talking about the research I do, but I'm going to talk more about my background, and hopefully you'll be able to see a little bit of yourself in this background as well and realize that starting at a community college is a fantastic opportunity and it can lead to some absolutely fantastic things as you go forward with your college career. So I grew up in southern New Jersey in a little tiny town called Laureldale. It was so tiny that you can't even find it if you look for it on a map, but it was in the middle of the Pine Barrens of New Jersey. And it was between two other towns. One, Mays Landing, which is a picture that was taken about 10 years ago of downtown Mays Landing. And as you can see, it is quite the bustling metropolis there. And to give you an idea, when we're talking small town, when McDonald's opened a store in Mays Landing, we had a week-long celebration to welcome our McDonald's in town. The other town that we were between was Egg Harbor, which is kind of an interesting, again, little bustling metropolis there, in that the name harbor, and the city government actually has a harbor master, but there's no actual harbor there. So there's a harbor master that really doesn't do anything other than have a title in the town. I went to high school at a school that encompassed both of these towns. It's kind of interesting because if you go to the high school website these days and you look for distinguished alumni, one of the people who's at the top of the list is someone who is a competitive hot dog eater. So we're not exactly known in my hometown for having an aspiring career goals among the students that went through the program. Now, when I was younger, my family was not academic at all. My father did heavy construction work. My mother was a secretary, but then she quit and she was a stay-at-home housewife. And I was kind of the anomaly of the one that really loved science and loved learning. And my parents were very supportive, didn't understand me an awful lot, but very supportive. And when I was trying to think of what was I going to do after I graduated, at first my family said, well, you might consider becoming a lawyer because you will argue anything with anyone on either side of a question just to be arguing with someone. And it sounded kind of appealing, except for the fact that I couldn't imagine myself sitting in an office with a bunch of books and papers and whatever all day. When I was in high school, I was not very social, to put it mildly. I did like nature, and I came up with the absolutely brilliant idea at one point that I was going to go to Hawaii and become a cetacean biologist. I was going to study the humpback whales, and I was going to go to Hawaii and sing with the whales, except if I actually sang to the whales, they would all immediately migrate back to the Arctic to get away from my singing. So maybe not the best idea. Now, I don't know if any of you have to do this in high school anymore, but when I was in high school, they would give us these tests to help us decide what was our perfect career and what we should go into. And considering my antisocial nature at the time, they really were picking interesting careers for me, like being a forest ranger and sitting on top of a fire tower all by myself and looking for fires and not interacting with other people. So between what my parents were saying, my inclinations, the guidance I was getting at high school, which in retrospect really wasn't the best guidance in the world, I had no idea what I was going to do. My guidance counselor at high school decided that maybe I should look into joining the Army or the Air Force or the Navy, and they could help pay for my college. But, and I'm dating myself here, but when I went into looking at these things, the problem was that there was still a lot of discrimination against women. It's not as bad now. It is still there, but it was in full force when I was a high school student. And I was told that, well, if I joined the military, that I could have a career as a secretary, and that if I had a really understanding commanding officer, I might be able to pick up a course or two in the evenings, as long as it didn't interfere with my work. Well, that had about as much appeal as being a lawyer. So no, that was not going to be my path either. So I went to a local community college. Lasted less than a semester and dropped out very promptly because I did not know what I wanted to do with my life. I got a job working for Prudential Insurance. Yes, I have no problem naming them. Yes, it was a truly, deeply horrendous experience. I spent several years processing Medicare claims and going absolutely bonkers again with the tedium of the work and the rampant discrimination that took place in business at that time. So I said, okay, we've tried everything else. Let's try going back to college. So I went back to that community college. Still had absolutely no idea what I was going to do. I knew I liked science. I knew I cared about the environment and the problems that we were causing in the environment, but no idea. I took every science course I could take. I took math, I took physics, I took chemistry, I took all the biology courses. Now, this school had a very strong nursing program, and they had a microbiology course that realistically was geared toward the nursing program. But the professor was wonderful, and he became my advisor. And when I took the microbiology course, because, well, it's a biology course and I have to take every science course I can get into, in that course, we all had to do a research paper. And all the other students are, oh, I'm going to study this disease, now I'm going to study that disease, now I'm going to study some other disease. And I listened to what they were talking about and said, ew, I don't want to study these diseases. And the professor, who was my advisor, came to me and said, I've never done this for a student before, but I'm going to do it for you. I'm going to give you the topic of your paper. And he handed me a bunch of research articles in the area of bioremediation, which was using naturally occurring microbacteria in the environment that could clean up the environment, that degraded toxic chemicals in the environment. And I read these papers and it was, oh my God, this is amazing. This is what I want to study. How we can use nature to clean up the environmental problems that we have in the country. So after I finished my degree in chemistry at the community college, I went to a local 4-year school. Didn't have any graduate programs. It was simply an undergraduate school. The school was interesting. It was definitely hippie central at the time. One of the most common things that students did at this school was wander the lakes and the shorelines and the woods around campus and try to find as many psychedelic mushrooms as they could. I did not participate in this particular activity, but it was a well-known activity at this school. But again, I lucked out in having wonderful, wonderful advisors who kind of took me under their wing and made sure that I stayed on the right track and took the courses that I needed to take. And they were hard courses, but they were courses that stood me in good stead as I moved forward in my career. One of the other things that happened here is I was trying to decide, did I want to go to graduate school or did I want to get a job? I was pursuing a biology degree at the college, but I was friends with the head of the chemistry department. And I took so many chemistry courses, he made a deal with me that if I got into a graduate school program that I was really excited about, I would graduate with my degree in biology. But if I decided, no, I'm going to go for a job, he let me switch my major to chemistry simply because chemists tend to make more money than biologists do in the job market. Fortunately, I finally made up my mind that I was going to go to graduate school. I was going to follow that original dream and get a degree in microbiology and study how to clean up the environment using microbes. So I kept my degree in biology, graduated, and went up to Rutgers University. They have an amazing program in microbiology and wonderful, wonderful people there. And I was able to get both my master's and my PhD at Rutgers. But then the question was, okay, now what? And I was looking for jobs, looking for postdocs, which are additional study opportunities in microbiology, in bioremediation. And I stumbled across someone at the University of Washington. And what he was doing was not looking at microbes, but he was looking at how plants could take up these toxins that were existing in our environment, and the plants broke them down rather than the bacteria. Now, I love nature, I love plants, and it was, oh my God, this is the logical next step. So I packed everything up, and my husband absolutely followed me out there. So we moved from New Jersey out to Seattle, Washington, where I did my postdoc in the biochemistry department, studying how to use plants to clean up environmental issues. My advisor at Washington, again, was a fantastic individual. He was a pioneer in the field, and he actually pushed for me to get my first faculty position at the University of Washington. And I'm showing this picture because I don't know if you can see my arrow, but this was my office right up here in this beautiful, beautiful building at the University of Washington. And I worked there for a number of years, but I was doing a lot of work for the Department of Energy, and they were paying me a fair amount of money to do research to help them clean up all the contamination that they had around the country. And they actually managed to lure me away from Seattle, Washington, to go, of all places, to the University of South Carolina. And I always tell people that this is true proof that my husband loves me, that he followed me not only from New Jersey to Seattle, but from Seattle to South Carolina. Slightly different in the political outlook between the two areas, but follow me he did. And I had this very interesting position that was part-time at the University of South Carolina. Excuse me. Didn't want to make anyone deaf by coughing in their ears. Part-time at the Savannah River Ecology Lab, and this is one of the premier ecological labs in the country. And part-time at the Savannah River nuclear site. Sorry, everyone. This particular Department of Energy site was one of the largest in the country. And just to give you a little bit of background, that the Department of Energy, what we think of as the Department of Energy now, that is involved in clean fuel, it is involved in helping people to develop clean energy, energy efficient appliances. The Department of Energy was nothing like that when I started working there. The Department of Energy at its start was involved in the production of energy weapons, i.e. nuclear weapons. These sites, the Department of Energy sites, are all over the country. And the Department of Energy actually did something incredibly smart in the 1950s and the 1960s. At the height of the Cold War, we were making lots and lots of bombs. And we were always concerned about what other people were going to find out about our programs. So the Department of Energy took the making of weapons and broke it down, that this site would purify the uranium, and this site would build the hardware, and this site would do the testing, and this site would do the assembly. And for every type of process, there was at least 2 labs around the country doing the same type of work. And they were far enough away that if there was a war and a site got bombed, the other site would still be safe. And because everything was broken up, the information and the technology of how to build these weapons was never all in one place. It was at labs all over the country. So the Savannah River site where I worked was one of the 2 places in the country where they processed and produced the high-level uranium and plutonium and tritium that was used in making the weapons. And as you might imagine, on sites like this, there's a lot of contamination on these sites. So I worked there working with the Department of Energy and helping to clean up these really incredibly contaminated sites. Later on, I moved up to Long Island and I worked at another Department of Energy site, Brookhaven National Lab, and this is where I started getting into not only doing the environmental remediation, but also looking at growing plants for clean energy, for biofuels work. But even though I did this work for the Department of Energy, I really, really missed teaching. I missed interacting with students. When I was at Washington, when I was at the University of South Carolina, I always had labs full of students. Didn't have that when I worked for the Department of Energy. So I was asked to give a seminar at SUNY ESF about the work I was doing at Brookhaven National Lab, and they kind of lured me back and said, wouldn't you like to get back into teaching, and wouldn't you like coming back here? And it was really very reminiscent of the type of labs I had at the University of Washington. So I agreed to come back to academia. So now that I can do the research I want to do, rather than what some manager at the Department of Energy is telling me I have to do, what do I do? Well, I do that phytoremediation work. I've also had students in the lab looking at the potential toxicity of nanoparticles to plants, hyperspectral imaging, and I will explain that in a moment, the bioenergy work, going back to my microbiology days and my love of microbes, looking at how plants and microbes interact, and then a couple new areas, horticultural therapy, living walls, and phytopharmaceuticals. So I'll talk just a minute about each of these. So phytoremediation is, as you can see here, a plant-based system that will either take up and concentrate or take up and degrade contaminants in the environment. The work that I have done has been incredibly rewarding. And because I've had this very, very diverse background coming into this area, I've had some really diverse projects. So we've looked at the ability of plants to take up and degrade organic contaminants, industrial chemicals. I've had students that have looked at taking up explosive compounds from the military and how they degrade those. We've also had students in the lab that have looked at trying to understand on the chemical and the genetic level how the plants are actually able to do this. And can we manipulate the plants to make them super degraders, that they can withstand higher levels of toxins and degrade even more contaminants. We've taken this out and done field trials. Some of these trials were in Washington, some of them were in South Carolina, some of them have been here, where we've looked again at these industrial contaminants. We've looked at mercury, we've looked at gasoline contaminants in dredged sediments, and we've looked at them outside rather than in the lab. And probably the most rewarding aspect of the work I've done is when we actually get out onto contaminated sites and plant these trees and start cleaning up the environment. So it's not just the theoretical, it's actually getting out in the field and working with these communities and working with the people who are being impacted by these contaminants. The photo in the center, that's one of my graduate students from Washington, Mary, and we worked on a site that was contaminated with agricultural chemicals. So we had pesticides, herbicides, insecticides, petroleum compounds from a leaking gas tank where they would fuel up the trucks that delivered these contaminants, from fertilizer that got into the groundwater and was poisoning the drinking water of this town. And this was one of the examples that was just absolutely amazing to me of working with the community. So we're out there using our plants to clean up the groundwater that's being poisoned by these chemicals. And the community just rallied around everything we were doing. So we had a weed problem on our site, and the local Boy Scout troop for a project went out and worked with us and helped us control the weeds on the site. When we needed to come out and plow, local farmers would come out with their equipment and help us maintain the field sites. So it wasn't just us out there. It was the whole community becoming involved in these projects to help clean up the soil and the groundwater and the whole environment in which people lived. Now, one of the things that we've done is a lot of involvement with the communities, a lot of this field work, a lot of application. The picture up in the top left, that was me out on one of our sites, and I'll just tell you a little bit of a story about this one, in that all of my students had to have high-level training in how to work on contaminated sites, and I convinced the site managers, which was the Navy, that I didn't need the training because I wasn't going to be actually working on the site. I would just supervise my students. Well, we had to go out and dig holes to see how deep the roots were going and see if they were getting to the contaminated water and were they cleaning it up. It was kind of a dangerous site. It was an old landfill, and I didn't want my students going down in the holes to do this. So I was the one that climbed into the hole. I was the one that was doing this type of work. And I remember at one point someone yelling, "Get out of the hole, get out of the hole." And as I'm coming out of the hole, there is the base commander waiting for me as I come up out of the hole. And he said, "I thought you weren't going to be working on this site." And I said, yeah, I did say that, didn't I? And he just fortunately shook his head and wandered away. But when we went out onto these sites, we would stay for several days sometimes working out in the field. And my idea of what to do in the evening was to go back to the hotel or the motel and collapse. I have two rules for hotels or motels when we're working field sites is no other critters in the bed with me and hot water in the shower. Those are all the amenities that I need. And for a while, I would let my students pick the places we would be staying. This stopped after this incident. So I don't know how many of you ever watch classic horror films, but there was a producer that would make these absolutely classic horror films, Alfred Hitchcock. And one of his most famous was Psycho. And this was about this crazy person that would run a motel and he would kill the guests in the motel. And the name of the motel was the Bates Motel. Norman Bates was the psycho. And my students booked us into a motel at one of our field sites, the Bates Motel. I never let my students pick the motels again after this. I stay in a lot of interesting places, but again, we looked at how nanoparticles can impact plants. And this is important because, well, nanomaterials are being used in a lot of different materials, a lot of different applications for energy, for computing, for construction of new materials. They're also being proposed to be used as pesticides and put on crop plants. So my students and I thought it would be rather interesting to find out, do the plants take up these nanoparticles and are they toxic to the plants as well as the diseases that they're being sprayed on the plants to control? I mentioned hyperspectral imaging, and this is something that I'm going to need you to participate a little bit with me. All right, so hyperspectral imaging, the amount of light that we can see is very, very small. The visible spectrum is very small. And hyperspectral imaging is looking at not just the visual wavelengths, what we can see with our eyes, but also the ultraviolet, the infrared, and either further wavelengths out. All right, so why is this important? Well, I want you to look around wherever you're sitting and look at something that's really colorful. Okay, and we look at that and it's has a bright color to it. But everything in our universe, in our world, is made up of atoms. And I can tell you right now that there are no green atoms or red atoms or blue atoms. So how is this object that you're looking at have color? Well, it's because light, whether that light is coming from a light bulb in your room or from the sun, has different wavelengths, different amounts of energy. And as it hits that object, some of the wavelengths of light are absorbed by the object and some are reflected. And the reflected light is what we see. So if you're looking at something that's bright red, it's not because the atoms that make it up are red. It's because the light that's reflected back towards you is in the red wavelength. And that's the same for all the different colors. So why is this interesting? Well, NASA came up with the idea that maybe if we scanned leaves of plants, the wavelengths of light that were reflected back changed if the plant was exposed to an environmental contaminant. So why would NASA care about this? Well, NASA shoots off a lot of really big rockets, and this is a picture of the Saturn V rocket, still the largest rocket that has ever taken off from our planet. This rocket was huge. It was an absolute monster. This is what the Saturn V looked like when it was being transported. This rocket would burn through 13 tons of fuel per second. It would reach 25,000 miles per hour. It was essentially a missile. Well, how do you test this to make sure when you have an astronaut sitting on top of it that it doesn't go boom? And the way they would test these rockets is they would take them individually and strap them to these huge buildings. And they would fire up the rocket and it would be chained to this building and they would make sure that it worked properly. And those two big tanks at the top were filled with industrial chemicals that they would spray down next to the rocket to make sure that the whole thing didn't catch on fire. And if you looked on the back side of it, this is what it looked like. And you'll notice this kind of sloping bottom and the square hole where the thrust from the rocket would shoot through. And this sliding bottom would make sure that the rocket did not have anything solid to push off against to allow it to take off and just take off with the entire building along with it. Well, the areas around these test facilities were incredibly contaminated with all these chemicals. So we would go out onto these sites, collect plant leaves, and scan them to see whether or not exposure to these chemicals changed the reflected light. Not in the visible range, but outside the range that we could see. And truthfully, we can. We can tell whether a plant is growing in contaminated soil based on the light that's reflected back off it. We're also looking at cleaning up the forever chemicals, the fluorinated chemicals, and the more we learn about them, the more health impacts that are discovered. And these chemicals are really important because they have fluorine attached to them. And fluorine makes them incredibly hard to degrade. And why do we care about them? Is because they're used in everything. Our entire environment is inundated with these compounds. Nonstick cookware. Water-resistant clothing is made with these chemicals. Stain-resistant furniture. Food packaging. The inside of your microwave popcorn bag is coated with these chemicals. Firefighting foam that the military and airports and the Department of Energy used is made up of these chemicals. Even things like dental floss are coated with these chemicals. They are everywhere. So there's close to 5,000 different chemicals. We're not looking at all 5,000, but we're looking at the ability of plants to take them up out of water. We're looking at plants that grow in the ground, taking it up. And NASA is also funding us to see whether or not plants that take up the chemicals, can we see differences in the reflected light again? I'm going to just touch on a few other things quickly. So we're still using plants for biofuel. We're, again, looking to see whether certain bacteria can help make the plants grow faster. and more healthy. We're looking at the potential for growing pharmaceutical compounds in plants and using living walls or green walls to clean up the waste from breweries and wineries and food processing plants. And the most recent one that we're looking at is looking at using plants to improve people's lives directly. So there's a lot of information out in the media, out in the news, looking at how if you get out into nature, it improves your health. But what about people who are in nursing homes or hospitals? So we have a very large program where we go into hospitals and nursing homes and bring gardening and nature-based activities to the people in those facilities to try to improve their health outcomes. Now, in addition to this, I have been traveling all over the world for years to try to bring these technologies to countries that don't have the money to clean up the legacy contaminants they're dealing with. There is an International Journal of Phytoremediation, and I am the editor for that journal. And there's actually a society that deals with or promotes the use of these plants for these projects that improve the environment. And I had the honor of being the founding president of that particular society. And because I've traveled all over the world, a lot of these contacts I have been using to develop international programs that can be partnered here at ESF. So we have a program where students from Thailand come here and our students can go and take classes in Thailand. This one can be controversial. We've done a lot of work with universities in Siberia, and a lot of my colleagues over there are absolutely appalled at what's going on in the political climate these days. And it's really heartbreaking that I'm not able to work with these amazing, amazing students and scientists until these issues get resolved. Also have a project going with Lincoln University in New Zealand, which has an incredible nature and environmental program there, as well as the Korea University of Science and Technology, where we're partnering with their institute that is involved in studying traditional Oriental medicine and the plants that are used to treat diseases and how maybe some of these things are really pretty darn good and maybe even better than some of the medicine we're using. And the most recent project that we've been working on is with the Pavlodar State University in Kazakhstan, again, developing their international environmental science program. So at ESF, I am the coordinator for the environmental health major, and I'll be talking to students about that, and hopefully someone will be interested in attending that. I also coordinate several minors at the college and do the pre-health advising for students interested in going into medicine or veterinarian science. And last year, because, well, I didn't have enough to do, I agreed to become the chair of chemistry. And in my spare time, ironically, my two favorite things are gardening, as you can see from the front of my house, and petting my dogs, who are absolute loves and help to keep me sane by giving me something to do other than science all day long. So I don't know if there are any questions, but I will be very, very happy to answer any questions that anyone has about my career path, the research that we're doing, or why I truly believe that starting at a community college can be a phenomenal path forward for anyone.
Thank you very much, Dr. Newman. I myself have learned quite a few new things, and we do have a few questions.
Okay.
The first one being that now knowing that these PFOAs and PFOSs are pretty much everywhere, what plants have you put in your yard to maybe possibly clean up a little?
I actually haven't put anything in my yard yet to do that. I am hopeful that my yard isn't too contaminated. Uh, but we found several aquatic plants that are incredibly good. So water lettuce and water hyacinth are very good at taking up these compounds. We're looking at plants like poplar trees and willows, also incredibly good at taking up these compounds. And I mentioned that these carbon fluorine bonds are incredibly strong, which is why they persist in the environment. So we're looking at plants that have unique metabolic pathways to see whether or not they have the potential for breaking these plants down. So rather than just taking them up and accumulating them, can we find plants that can actually break down these toxins? So we're looking at things like clover, which has the root nodules. We're looking at plants like castor bean, which have really unique pathways and actually incorporate fluorine into other molecules. And we're kind of like, well, if they can add it, maybe they can take it off as well.
Fascinating. I'm happy to hear that you're studying clover. I'm in the process of converting my yard to a clover field. So
There you go. Okay.
I'll be keeping an eye out on the results there.
Okay.
Another question is, if you could go back, what would you do differently? Your work at the insurance company kicked this off. Do you wish you hadn't stuck it out as long? If you could do it all over, what would it look like?
If I could do it all over, I probably would not have quit when I was in the college the first time. I think my starting at the community college was absolutely the right path for me to take because I didn't know what I wanted to do. And starting there gave me the opportunity to explore so many different areas until, with the help of an amazing advisor, I wound up coming across what I really wanted to do. But yeah, working at that insurance company processing Medicare claims, yeah, that I would probably give a pass on that.
Something you mentioned is a theme that I've noticed with many of our speakers who share their journey with us is that there was one person or one or two people that really seemed to make that difference, whether it was a mentor or a professor that took an interest. What would you say to a student? If you sat down with our students, which you are going to be doing in November, by the way,
Yes.
what would you tell them? How should they, where do you find these mentors? How do you go about getting in touch with these people?
Well, when you start at a school like ESF, you get assigned a mentor. And sometimes this is going to be someone that you just really, really click with, and they're going to be fantastic at guiding you. But there's no guarantee that's going to happen. It's a gamble. And what I would advise any student is that if you have a mentor that you're not clicking with, find a new one because you need someone with that experience that can give you that guidance. So if you take a course with a professor and you just absolutely love this professor, go and talk to them and see if you could switch and have them as an advisor. If you take a course and the professor mentions a field that you find absolutely amazing, go and talk to that professor and say, well, this really interests me. Can you be my advisor or can you recommend someone to be my advisor who's an expert in this area? So don't settle. If you don't have an advisor that you feel is going to inspire you, take the initiative and find a new one. Talk to your friends, talk to other people, see if they have an advisor that they absolutely love and go talk to them. If you talk to a friend and they say, oh no, don't talk to my advisor, they're horrible, don't go and talk to that one. But be your own advocate. I was incredibly lucky that I had wonderful, wonderful mentors. But, if you don't have someone that can do that, reach out, find someone else who can. Stand up and advocate for yourself.
That is the advice we give our students often. Speak up and continue to speak up until you find
Yes,
what you're looking for.
exactly.
Now, something else you said piqued my interest. You said if you could do it over, you probably would have stuck it out the first go around in college. And
Hmm.
this is a situation we find a lot with our students, that life circumstances, a
Yeah.
lack of interest, or just things out of their control cause them to discontinue their education and then come back at a later time. And something that we fight really hard for is trying to help them figure out how to stay, how not to drop out that first go around. What is some advice that you would give a student who is on that cusp of maybe this is not for me?
Well, to be honest, college isn't for everyone. Um, People can have incredible careers without going to college. But if you're in college already, you obviously thought at some point that this was the right way to go. One of the things who students who aren't 100% sure can try is maybe go part-time. So I started full-time. Really, I didn't know what I wanted to do in my life and wound up dropping out. But when I came back, I didn't come back full-time. I still had a job. I was supporting myself. I came back part-time and I took one class a semester. Then I took two classes a semester. And then I said, okay, I'm really starting to figure out what I want to do here. And then I came back full-time. So if life intrudes, and it happens, you don't have to give up everything. Maybe you can pick one or two courses that really speak to you and you do it part-time. So I was part-time when I came back to the community college. After I graduated, I got a job at the community college and I continued my 4-year degree part-time, taking one or two courses a semester while working full-time at the community college. It was when I reached a point where I figured out that I was going to be a student for the next 20 years if I didn't get my act together, that I finally said, okay, this is it, saved up the money, quit work, and finished up my degree full time, and then went on to graduate school from there. So it doesn't have to be you go in, you're full time, you get your degree in a set number of years. It doesn't have to be that way. If it works that way, that is wonderful, and congratulations. But that's not the way it works for everybody. So I was a part-time student for 6 years, working various jobs off and on. Yeah, I'm really dating myself here. But anyway, before I finally said, okay, I now know exactly what I want to do. And that's when I went for it. So
That is
if,
certainly a path that many of our students will be able to relate to. But I can't take this class on Wednesdays because I'm at work is something I
mhm,
hear very often. And
yeah,
to see you advocating for that and showing them, here's what you can do while working.
yeah.
Thank you for that. Now, to anyone listening, Dr. Newman will be back to speak to OCC students in a couple of weeks, November 4th. Keep an eye on your inboxes and you'll be able to have a conversation with her. Now, thank you very, very much for your time and for sharing your story, Dr. Newman.
You are quite welcome. And again, I hope that people who are listening to this or watching this are going to realize that, starting at a community college can be a really phenomenal starting point of moving forward with your career goals, with your life goals. And there's lots of paths forward, and every person's is going to be different.
Thank you very much.
All right.
Bye-bye.
Thank you. Bye-bye.